In this video, we're going to solve solve a fourth degree equation in quadratic form. It says find all the solutions, including imaginary solutions, if they exist, of the following equation. Now, one thing we need to note is that x to the fourth is really x squared, right? Because power to a power means multiply the power, so we get x to the fourth there. So to start this problem, we're going to do a nifty little substitution where we can say that u is equal to x squared. And the reason we do that is because of this property here. That means that I can now write this equation as, represent the x squared with u, so I can say u squared. So by doing the substitution, I can make this into a quadratic essentially, because I would have u squared minus u is x squared, so it would be minus 10u plus 9 equals 0. And now it allows us to do some factoring here. The factors of 9 that add to negative 10 will be negative 9 and 1. Sorry, negative 9 and negative 1. So I end up with u minus 9, u minus 1 when I factor that. I can use zero product property. So I get u minus 9 is equal to 0, or u minus 1 is equal to 0. Kind of messed it up. Let me write that better. U minus 1 equals 0. Add the 9 over, you get u equal 9, or u is equal to 1. Now we found out what u is, but we're looking for what x is. Well, we know that u is x squared, so we can resubstitute that back in. So you have x squared equals 9, or resubstitute this back in, x squared equals 1. Square root each side, so we get square root of x squared is equal to plus minus the root of 9, or square root of x squared is equal to plus and minus the root of 1. So I get x is equal to 9, or x is equal to negative 9, or x is equal to 1, or x is equal to negative 1. Hope I screwed that up. That shouldn't be 9. I'm doing the root of 9. That should be 3. All right, going too fast. X is equal to 3, or x is equal to negative 3, or x is equal to 1, or x is equal to negative 1. Those are your four solutions. Now, let me show you a different way you could have started. So we didn't necessarily have to do this substitution. If you notice that right away, this x squared term is half of the x to the fourth, you could have written this as x squared minus 9 times x squared minus 1. Basically treat it like a quadratic, but instead of having x and x here, we have x squared and x squared because that's what multiplies to be x to the fourth. So you still get your negative 9x squared minus 1x squared would be the negative 10x squared, and then you get negative 9 times negative 1, which is positive 9. You could use zero product property, and we would end up with the exact same spot we were over here, where we get x squared equal 9 or x squared equal 1, and then we can solve. Let's try a second example. So again, x squared squared is equal to x to the fourth. So we can say that u is equal to x squared. So we end up with u squared is x to the fourth. So we can represent that now as u squared plus 13. X squared we know is u, so we can say 13u plus 36 equal to 0. What are the factors of 36 that add to 13? Well, that would be 9 and 4. So we're going to say u plus 9 times u plus 4 equal to 0. The zero product property, we get u plus 9 equals 0, or u plus 4 is equal to 0. Subtract the 9 over, we get u is equal to negative 9, or subtract the 4 over, u is equal to negative 4. Let's resubstitute x squared for u, so we get x squared is equal to negative 9, or x squared is equal to negative 4. Let's do the square root on each side. So we get plus minus the root of negative 9, or Square root of x squared is equal to square root of -4, but that's got to be plus minus. Whenever I do the root of -9, remember that's just going to be an I coming out front, so I end up with x is equal to, this would be positive 3i, or x is equal to negative 3i, or x is equal to 2i, or x is equal to negative 2i. Remember, this exponent is telling you the max number of solutions.